In this video, we're going to talk about the code for project number 4. If you're watching this, you should have made a good faith effort at completing the hideShips method for your progress check. Remember that hideShips, that's the method that allows you to return a valid board object. That's important. It's how you set up your game board that your opponent will be attacking. And it refers you to the board class for details about how to set up a valid board. And it warns you that you should not return the same board twice in a row. So 2 successive calls to your hideship method should always return different answers. That's for your own protection, because if you use the same board every time you play Battleship, just think about that. Like if you always hid your ships, say in the top row of your Battleship board, and you were playing like a friend or a family member or something, after about the 3rd time you did that, they'd be onto you and be like, they always put the ships in the same place. I'm just going to guess those right away. And they'd be able to defeat you really quickly. So having some variance in the boards that you create is good because it allows the element of surprise. It allows your opponent to or it prevents your opponent from being able to anticipate where you might put your ships. So first, as our first step in creating the hideShips method, we're going to do like a really basic solution where we don't worry about that warning and just always return the same board. If you go to the board class, you'll notice that it has one constructor. It is a non-default constructor. We can tell that because it takes parameters right here. It takes a 2-dimensional character array, and that's the character array that contains all of your ships. You can tell that because it tells you up here in the comments that it has to, the 2-dimensional array that you pass in as an argument to this method has to represent a legitimate board. Otherwise, it's going to throw an exception. A legitimate board is one that has exactly 5 ships. They have to have the proper length. The aircraft carrier has to be length 5. Battleship has to be length 4. The submarine and destroyer are both length 3, and the patrol boat is length 2. It says set all the other squares to an empty space character. So those are the only valid things that could be on your game board. When we did the lab, we had put little periods in all the empty spaces, which was easy. It made it easier for us to keep track of like what the board looked like and which spaces were empty and which spaces were full. But in the project, you don't want to put any periods in the spaces. You only want to have spaces or these characters that represent ships. So the constructor, it checks to make sure your board's legitimate and throws an exception if it's not. And then it sets up a separate 2-dimensional array called fired squares where it sets everything to be false. In other words, none of your squares have been fired at yet because you're just starting the game. This is like the first step in setting things up. So inside your hideShips method, you want to call that board constructor. So we're going to have something like board, my board equals new board. And then we found out that we have to put a 2-dimensional array in here as a parameter. So we're going to have to set that up inside our hideShips method. And so the easiest way to do that is to create a 2-dimensional character array. I'm calling it grid. You can call it whatever you want. And you can initialize that just using kind of our standard method where you list out all of the 100 squares, separating them into rows of 10. So if you wanted like your whole top row to be blanks, you'd have blank, 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 blank. I think I'm up to 7. Blank, blank, blank. And that's our first row. Super. And then you put a comma, and then if you want to, I think it's visually easier if you put the next row on the next line, and Java's okay with that. It doesn't care that you have extra spaces in there. And you can just copy and paste the row to create your second row. And if you wanted to fill in some ships on that row, you could put them in there, like the aircraft carrier. It's supposed to have 5 spaces in it, so I can put 5 A's going across that row. You can place your ships anywhere you want, horizontally or vertically, but not diagonally. And just set up your whole grid that way, so that we don't have to watch me type in all 100 spaces. I copied and pasted one. Oops, I forgot about it. Hold on, it's in my email. Well, I'll just type the whole thing. Go back to my part that I already created. So that was one row. We all want another row of spaces. And then I'm going to do a row and put my battleship in there. That has 4 spaces in it. And then put another blank row, and then have the submarine in that row. Maybe I'll put the destroyer in that row too. Maybe I'll put it like going down. Destroyer, destroyer, destroyer. And then the last ship I need to hide is my patrol boat. I'll put that going down right here in this row and the row after it. All right, how many rows do I have so far? I have 1, 2, 3, 4, 5, 6, 7, 8. So now I need 2 more rows of blanks to finish out my ship board. So I've put in all the spaces and all the locations for the ships, just initializing that 2-dimensional array. And then I want to use that 2-dimensional array as my argument when I call the board constructor. And then eventually you want to be able to return the value of my board. That's because your hideShips method is required to return a board object that has to be the return value for the method. Okay, so you can see that Java is complaining and telling me that I have an unhandled exception here. And that's because the board method, remember, if your board's not valid, it throws an exception. And so we have to handle that. Remember, the 2 options for handling are we could specify it. We could put up here, this throws the exception. But that would require us to change this signature for how this method works. And we don't want to do that because that'll make it not work with the other code that's in our Battleship tester file and so forth. So our only option is to catch the exception. We have to add a try catch block here in our code. Awesome. And the exception could possibly happen whenever we create this new board. So I'm going to put my code in there, my board equals new board grid. And so now my code that potentially throws the exception is protected. It's in here. And in my catch block, I can just print out an error message, make it something that will allow you to know that this is your error message and that it's occurring because your grid was invalid. And that should only print while you're debugging things. Once you get your hideShips method set up, you should never get that exception. All right, so at this point, our code's looking pretty good. We still have one more error in here. It's telling us syntax error, my board might not have been initialized. That's because we declared my board up here, and we need to like assign it an initial value so that there's definitely something in my board when it gets returned. If you want to initialize my board to have a value but not put any good code in there, then you want to initialize it to null. That's that special reserved word that means this has been initialized, but it does not storing anything yet. So again, the code for our hideShips method, basic solution, putting in a 2-dimensional array, just literal values. Then we're using that to set up the board. We had to do a little bit of extra work here because of the exception handling. We had to initialize the board to null, then call the non-default constructor for the board class using our 2-dimensional character array, and then finally returning the board. So at this point, we're ready to run our code. We got rid of all the syntax errors. When you run, it's going to play the game. Now, the game's not very interesting because you didn't actually write the method that attacks your opponent. So it's just doing nothing for 100 turns, and then it automatically stops after 100 turns. I want to be able to scroll so I can get up to the top faster. All right, cool. So it prints out my initial game board, and you can see that this matches the game board that I created. It has the aircraft carrier, the battleship, the destroyer, the submarine, and the patrol boat. You can see them all there. And it's printing player A's game board, that's this first one, and then player B's game board. And since I coded my battleship player so that it always produces a static board, they both have that same solution. And that's completely fine. You should expect that when you are running your code. So cool, that's the basic solution for the hideShips method. Now, of course, you want to take this a little bit further. Remember, you can't return the same board twice in a row. So in my battleship tester class, remember, it plays multiple games. And so it's going to call that hideship method for game number 1, and then it'll complete game number 1, and then it'll call it again for game number 2. And so you want the board for game 2 to be different than the board for game 1. So one way you can do that is by creating a instance variable in your battleship player class, a data field like Boolean value that stores information about which game it is. You could have something like, is it a odd numbered game, and set that to be false initially, because initially we're on game 0. And then inside your hideShips method, every time that method's called, you could change the game of name. You could change the value of odd numbered game so that it was updated. And then in here, you could use that value to test whether you wanted to use this grid or whether you wanted to use an alternate grid in creating your game board. That is the simplest possible code that you can create that'll satisfy the project requirements and allow you to hide ships. There's certainly more complicated algorithms you could use to randomize your hideShips method. Some people will make 3 or 4 game boards and then create a random number generator that allows them to select one of those at random on each turn, or they'll do something that creates the whole game board specifically from random, where they create random number generators that pick a random row and column and orientation, and then test to make sure that's valid, and then place a ship on the game board. So any of those are valid options. In general, putting a lot of time into making fancy random game boards doesn't actually end up making your artificial intelligence that you're coding more successful. If you have several game boards and you rotate between them, even in a predictable way, usually it ends up that you get the same performance as somebody who's made like a fancier algorithm. And so if you're going to put a lot of time into making fancy solutions, I recommend spending your extra time in the Go method. That pays off more than spending lots of time creating a random algorithm for your hideShips method.